Okay, to start off our lesson 5, we're going to do a quick review of the method of common bases, which basically means if we have 2 to the x equals 16, in order to solve for that exponent x, we need to have common bases. So we want to be able to rewrite 16 so that it has a base of 2 to match the left side. So we can actually rewrite 16 as 2 to the 4th. Once this happens, we can cancel out our bases and we get x is equal to 4. Another way you might see it in part C is we can rewrite 1 over 25 as 1 over 5 squared, right? 5 and 5 are going to have the same base. The last thing we have to do is actually just bring that 5 up to the numerator, and we do that by negating the exponent. So we get 5 to the negative 2, we can cancel our bases, and we get x is equal to negative 2. In the case of part D, we could actually rewrite 16 as 4 squared and then have my x on the outside. All right, this is really going to be 4 to the 2x equals 4 to the 1. This is technically a 1. Canceling out our 4's, we'll get 2x is equal to 1. Divide both sides by 2, and x is equal to 1/2. So in the case of that last one, we had to manipulate the right side so that they could have a common base with the left side. Just a reminder that when you have a power to a power, you're just multiplying. So this is 2 to the 3x. All right, in part C, we're going to distribute that negative, and it will be 5 to the negative 3x plus 7. All right, and then again in part D, we're going to distribute. So this would be 4 to the negative 3 plus 3x squared. So power to power just means we are multiplying those two exponents. So if we look at exercise 3, our goal is to get a common base. Well, we can certainly rewrite 8 as 2 cubed, and then my x is on the outside. And we can rewrite 32 as 2 to the 5th. Now the reason why I chose to rewrite it using 2's as our base is because I knew 8 squared was already 64. It was already higher than that 32 than the right side. So I tried to use a more simpler common base so we could simplify this. Going ahead and getting rid of the bases, we're going to get 3x is equal to 5. Dividing both sides by 3, you will get that x is equal to 5/3. So don't be afraid of fractions. You will get fractions here. Once again, looking at B, I can see that probably it's going to be best to simplify using a base of 3. So we can rewrite 9 as 3 squared, and then the 2x plus 1 is on the outside of that. And we can rewrite 27 as 3 cubed. Now, dropping our bases and then making sure we're distributing that 2, we're going to get 4x plus 2 is equal to 3. Subtract 2 from both sides, 4x is equal to 1. Divide both sides by 4, and x is equal to 1/4. All right, finally for part C, I'm looking at 25 and 125. I know that they're going to definitely have a common base of 5. So I'm going to rewrite 125 as 5 cubed to the x. I'm also going to rewrite 125 as 5 to the negative 2 to the 4 minus x. All right, not only is 25 5 squared, but I wanted to bring it up, so I changed the exponent to a negative. Now I can drop my bases, and I'm going to get 3x is equal to, I want to make sure I'm distributing my negative 2, so that's going to be a negative 8 plus 2x. I'm going to subtract a 2x from both sides, and I'll get that x is equal to a negative 8. For exercise 4, we're trying to find the solution set. So what I'd like you guys to do is rewrite this equation. Go ahead and solve for x, and then write the correct answer into Schoology. So this is your Schoology submission number 1. Let's look at a different type of situation. In example exercise 5, we've got 2 curves, and they're intersecting at this point. And we're trying to find the area of this rectangle right here. So for part A, in order to find the area of any rectangle, we know we need to find its base and its height, or its length and its width. All right, we need those 2 dimensions in order to find the area of a rectangle. So if we could find the coordinates of A, we would definitely know I'm going to label the coordinates of A as x, y. We know that the distance x would really be the base. And we would know that the distance y would really be the height. So by finding the coordinates of A, finding where they intersect, we could certainly get the base and the height. So the y coordinate, I'm going to actually type this out. All right, so the y coordinate will help us find the height, the x coordinate will help us find the base. Part C, find the area of the rectangle algebraically by finding the method, or using the method of common bases. Well, because we want to find this point of intersection, we know that the only way that they're going to intersect is if both of these functions equal one another. All right, and also just point out that this is at the origin, so that's why we can just find the x coordinate and the y coordinate, and we'll have our information for area. So we're trying to find this point of intersection A, so we want to know where these functions are equal to each other. We want to know where 4 to the x plus 5 halves is equal to 1/2 to the 2x plus 1. Well, looking at 1/2 and 4, I know that they're going to have definitely a common base of 2. So I can rewrite 4 as 2 squared, and then to the x plus 5 halves. And I can also rewrite 1/2 as 2 to the negative 1. As long as I bring it up to the numerator, I can change the x1 to negative. 2x plus 1. Now that I have common bases, I can go ahead and drop those bases, and then don't forget to distribute out and multiply. This is going to be 2x plus 5. 2 times 5 halves is 2. Is 5. And then distribute the negative, which is going to be negative 2x minus 1. From here, I'm going to add 2x to both sides. I'm going to subtract the 5 to get negative 6. Divide both sides by 4, and I'll get x is equal to negative 1.5. Now, even though we're dealing with a negative number, I know that a distance is really going to be positive. So although the coordinate might start with negative 1.5 for x, I know that the distance is actually going to be 1.5. Now, in order to find y, I can plug it into either one of these equations, the x into either one of these equations. I'm going to pause it and do it in this corner right here so we have some room. Okay, so in that corner you can see that I plugged, it's a little hard to see, but I did plug 1.5 in for x, got a result of 4, so therefore the area is going to be 4 times 1.5, length times width, to get an area of 6. What I'd like you to do is exercise 6 as part of Schoology submission number 2. And just keep in mind that they're only asking for an x coordinate, and they want to know where these two functions are going to intersect. So we know because they want to intersect, we're going to have to set this function equal to this function, and go ahead and, I know there's x's and a's in here, but just get it in terms of x. We just want the x coordinate. When you're done with that, you can make your submission, and then your mastery check is going to be numbers 1, B, C, D, and F, and then numbers 2, 3, 4, and 5.